Hello everyone. In this video we're going to talk about similar polygons. We're going to look at some examples here where we want to determine whether or not two shapes are similar. So in this example I have my polygon ABCD and EFGH, and I want to identify whether or not these two shapes here are similar. So first I'm going to look at my chart here that I created, and I have in the first column the sides on the first shape, and then in the second column I'm going to label my corresponding sides and then the side ratios. Okay, so here I have that my side length for AB is 15. Okay, so I'm going to put that down in my first column, and then I have that my side length for BC is 6. My side length for CD is 9. And then my side length for DA is 12. Okay, now I want to determine the corresponding sides looking at my shape EFGH. So here I see that AB and EF are corresponding sides. See how angle A and angle B both have these, well, angle A has this one curve and angle B has these two curves. You will see a similar idea when you look at angle E and angle F. Okay, and so EF is my corresponding side, and we can see that that length here is 10. Okay, next I'm going to look and determine my corresponding side for BC, and hopefully we all agree here that that's going to be FG. So here I'm going to write FG, and then its length here is 4. And then we also have that the corresponding side for CD is GH. And that has a length of 6. And then last but not least, HE is the corresponding side for DA, and that has length 8. Okay, so you want to recall how to determine the corresponding sides. If you weren't following me at first with the corresponding sides were for AB and EF, hopefully you were following me with the others. If not, please let me know. But basically you want to do is just look at these angles here, and you can see that angle A and angle E are corresponding angles, and angle B and angle F are corresponding angles, because see how they both have the same markings, and that will help you guide you with figuring out the corresponding sides. Okay, so now I want to figure out the side ratio. So here the side ratio would be 15 to 10, and we write that like 15 over 10. Okay, we start with the side on the first shape in the numerator, and then that would be divided by the corresponding side length. Okay, and so the next one would be 6 over 4, and then it would be 9 over 6, and then 12 over 8. Okay. So now what I want to determine is if all of these ratios are equal. So is 15 over 10 equal to 6 over 4 equal to 9 over 6, which is equal to 12 over 8. Here's the question. Okay, so it might be helpful to just reduce these fractions here, and then that way we can determine whether or not they're in fact the same. Okay, so if we divide, looking at 15 over 10, if we divide both the numerator and denominator by 5, right, because the greatest common factor that 15 and 10 have is 5, if we divide both the numerator and denominator by 5, we're going to get that this is 3 over 2. And then now looking at 6 over 4, we see that their greatest common factor is 2. And so I'm going to just say that this is now going to be 3 over 2, dividing both 6 by 2 and 4 by 2. You get that this is 3 over 2. And then looking at 9 over 6, we see that both 9 and 6 have a 3 as their greatest common factor. So we're going to divide both 9 and 6 by 3. And we see that this is going to be 3 over 2. And then for 12 and 8, we have that their greatest common factor is 4. And so dividing both top and bottom by 4, dividing both 12 and 8 by 4, we get that this is also going to be 3 over 2. So this brings us to, is 3 over 2 equal to 3 over 2 equal to 3 over 2 equal to 3 over 2? And the answer is yes. Right, of course 3 over 2 is equal to 3 over 2 equal to 3 over 2 equal to 3 over 2, right? It's the exact same number. Okay, and so when you're given ratios like this, where you're not sure whether or not they're the exact same, you want to put the ratio in simplest form by just reducing and simplifying the fraction. Okay, so that's what we did to 15 over 10, 6 over 4, 9 over 6, and 12 over 8. And so we got the answer was yes. So here, I'm just going to say that since the side ratios are the same, then the two shapes are similar. Using math notation, we have that ABCD is similar to EFGH. Okay, and so this little squiggle means similar.